Hi class, this video is for 9.1 example 6. Example 6, the letters R and theta represent polar coordinates. Write each equation, I suppose without plural, using rectangular coordinate, which is x comma y, okay? So before we start, we will write down some key things that are important for us. So the first thing that I'm going to remind you, it's r squared. It's always x squared plus y squared. Okay. Another one that's important is going to be x, okay, equals r times cosine of theta. And another one that's going to be important is going to be y equals r times sine of theta. These three things are so important for converting polar to rectangular and vice versa. All right, so here we go. A, r equals to cosine of theta plus 1. Right now, I know what r cosine of theta is, okay? But in your problem, it just gave me cosine of theta. So what I'm going to do is I'm going to rewrite my equation, okay? And from here, I would like to multiply both sides. Yes, you can do that, okay? What you do one side, you want to do to the other. And the reason I want to multiply both sides by r is that way I can get to this. Would you agree? I don't want to square both sides, which is also okay to do at times, okay? But squaring both sides here is not going to help me on the right side. So that's why we are going to multiply both sides by r instead of squaring both sides. Again, you can square both sides and you can multiply both sides by r. But squaring both sides on this one will not help us, okay? So r times r is r squared. Co times r distribute, that's r cosine of theta. 1 times r is r. Can you see that? This is right now x, okay? Now r squared, it's also x squared plus y squared. Remember, we're trying to convert it into rectangular. That means only x's and y's are left behind, okay? Now, this one says r is what I need to convert it out. Well, earlier, if r squared is x squared plus y squared, then r can be thought of as square root of x squared plus y squared. So yes, you can also drop it down just like that, okay? So this is as simplified as it's gonna get, okay? Now, if your book, okay, moves it so it equals to 0, that's also okay. So what if your book moves this to this side and then this to this side as well? Okay, so that means it's x squared. They want to put all the x's together, no big deal. Bring down the y squared. Move the radical on the left-hand side. So now you have a negative radical squared equals 0. That's also okay too if that's what the book has, okay? So if the book likes to write it equals to 0, it's okay. If you want to keep it as is, as long as it's in the simplest form, that's also okay too. So it's really up to you, okay? All right, next. R equals 3, okay? Now R is radius, right? So this is really saying radius is 3 units, right? With no angle given. Not funny, sometimes in polar coordinates they don't need to give you an angle, and sometimes they give you an angle without the radius. So I want you to think for a second, okay? What shape has a radius of 3 units all around, okay? Well, as you're thinking that out, I'm going to work this out manually. So they gave you r equals 3, okay? Now, this is the one that I will square both sides, okay? Because when I square both sides, now I have r squared equals 9. Unlike A, this one squaring both sides is still going to give me a nice solution, okay? Well, r squared can be now substituted with x squared plus y squared. That still equals to 9. I am done. This is all in rectangular form. Okay. Well, think about it. We studied this already. Okay. This is a circle. You're right. With a radius of 3. Okay. So this in rectangular will always be the same shape as polar. Okay. So polar is usually more like graphing around, using angle and radius. But in rectangular, we use x and y. Doesn't matter. Sometimes we can still get the same shape. This is the end of example 6.